I welcome Bill Reck, environmental engineer, and Kevin Ogles to our presentation today on planning and design of livestock watering systems. So, Bill, I'm getting ready to turn it over to you.
Thanks, Holly. All right, here we go. So today we're going to talk about livestock watering facility design, and primarily from a planning considerations perspective. And we're going to go over, I'm going to give you a lot of terminology and a little bit of design process. I want to point you towards a couple other webinars that we've recorded in the past, or that will augment the information that we're giving today. There is a watering facilities for managed grazing systems that was done by Kevin Ogles and Michael Hall. That's primarily a PowerPoint presentation. There's no audio with that, but it's a good presentation. And we also have a Windmills and water pumps for livestock water that was done by Dr. Carlos Rosencrans that was recorded. So you want to water your livestock, and today we're going to talk about how to plan for those kind of systems. Thinking about livestock watering systems and the pipeline and how to get the water from the source to the livestock. A lot of the system design is a lot like an irrigation system design. So I usually tell folks, think about irrigating your livestock. That's basically what we're doing. We're getting water to them, and hopefully it's not by a spray hose like we're showing here in the picture. But it's a simple, pretty simple design of this system, and it's simple hydraulics. There's some other things we have to think about in addition to just the piping of the water. We need to think about, and some of the things we're going to talk about is what's our water source, our delivery system. We're going to talk a little bit about tanks, pumps, pipelines, some other things we need to consider like fittings. And we're going to go through a little bit of design. I'm not going to give you a full design example. I'm going to give you some discussion of some different items in design. Some of the handouts that are there that are available for you have some very good examples for simple design of livestock watering systems, the actual design process. Let's talk about sources first. Typical sources are things like springs, streams. You could have a livestock pond on your property, wells, municipal, and rainfall. So let's look for what's your primary source of water going to be. If it's a municipal source, which is kind of rare, you're in luck because municipal sources have a pretty steady amount of source of pressure, and that you can get the flow rate from them fairly easily, and that it's a good source of water. But unfortunately, that municipal source is not available in a lot of our situations where we have livestock that we're going to be needing to water. But still, you want to check on its availability. Wells. Do you have a well? How reliable is it? These are some of the kind of questions we're going to talk about. Springs. One of the sources that we have a standard for spring development, where basically we're going to capture water from either a high water table system, where we're going to do some subsurface drainage and drain into a well, or we're going to capture some water off of the slope. There's how to do that is all about in that standard for spring development. Streams. A lot of times we're trying to get livestock away from a stream or out of a stream, so we may be fencing out a stream, but you still have the stream was the original water source. So now that we're fencing our livestock out of the stream, it's up to us to now provide access to water. And there's several different ways that you can do that, and we may be wanting to bring that water further away from a stream, so an in-stream watering may not always be the way that we want to go. Ponds, same kind of thing. A pond is in one place, but if we're doing something like rotational grazing where we divided it up into paddocks, each and every one of those paddocks may not have direct access to a pond for drinking water. So we need a livestock watering system. Wells, wells can be, if you have groundwater available, a great source of water. But there's some things that we need to consider. It's good to get a driller's report if that's available, to have an idea of what the delivery rate of water is going to be, how much drawdown depth there is, what's the condition of the water. In some cases, the well will already exist, and there will already be a pump associated with that well. So if we're going out and inventorying those kind of situations, we want to know what's the capacity of that pump. Let's talk a little bit about water troughs and tank size. Now, Kevin is going to cover this in more detail and talk about it from the perspective of the cow and headspace and water quantity. But we need to, some of the things we have to think about are we going to need a large tank or a small tank? Large tanks, you typically need larger tanks. If you have a larger head, you can have a lot of cows drinking at the same time. Large paddocks, sometimes rough terrain, or a slow delivery of water. If you have a slow delivery of water, say you have a well that's got a limited amount of capacity, you will want to fill up a trough over time because cows don't all drink all at once. They may come and you'll have drinking events, and you want to be able to have enough water for that drinking event. So your water source may not have a rapid enough delivery to meet the cow's demand right there during a drinking event, so you'll have to have enough storage in your tank for when that water, when they're there. Small tanks, small herds, small paddocks, but you're going to need rapid delivery of water because you wouldn't want the cow to drink that tank dry because then they may not drink as much water as they would normally take. You want them to take a normal amount of water. So you have to have a delivery system that can deliver water as fast as the number of cows that would be drinking out of the trough at once would take it. So if your flow rate's limited, trough size is going to be more important. We think about total daily demand, how much water do we need, number of animals times the amount of demand per day. That's how we come up with total demand. And typically we can size a trough for some percentage of that demand. And, that may vary by state depending on how dry you are, how hot you are. A typical size might be 50% of a daily demand. For meeting peak water demand, that's a different calculation, different way of sizing a trough. You'd want to know how much daily demand and how many events you had and how long that event had. So when the cows come to drink, how long do they come to drink so that we can size and make sure we have enough capacity of our system to meet that event demand of water by that group of cows coming to a trough all at once. Let's talk a little bit about kinds of tanks. Portable, permanent, frost-proof, and robust. So portable tanks. These are tanks that you typically move from pasture to pasture. If you have a rotational system set up with a lot of paddocks, typically you'll have a water source line with many access points to it, and you will move the trough and access a point to your source line whenever you move that portable tank. There's different types of these. You can still get some of these that are a little bigger, that have some storage to them. Permanent tanks. These are tanks that you don't move. You put these in strategic locations. Typically, they will have. You'll put them in an area where you can water more than one paddock at once. Some tanks will need to be more robust than others. I said robust, and that's because cows, and if your livestock is cows, can tend to move around a tank, and so you want a tank that's strong enough so the cows can't knock it around, can't move it, can't damage it in any way. Sometimes frost is a consideration, and so there are several types of frost-proof watering tanks that are out there and available. If you're in a situation where that's a consideration, you're going to want to choose tanks that are frost-proof. All right, let's move on now. We're going to talk about pipeline systems and some pumping options. Some of the type systems that are out there, we have gravity feed systems, solar-powered pumps, windmill-powered pumps. There's always gas or diesel, electric if electricity is close by and available, and talked already about municipal water supply. A gravity feed system is a system where you have a water source that's got at a higher elevation than where your troughs are. Look at the picture on the right. You'll see off in the distance you got a couple water troughs that are being fed by this pond up above, and it's a matter of having a line that goes from your pond or your source of water down to your trough with some sort of float valve that's going to control water access. Solar pumps are great for remote locations where you don't have electricity available. They're typically low maintenance. They can be expensive. They're not portable. You'll have to protect them from livestock. You don't want livestock bumping into your solar array because those things are expensive. And because we can have things like cloudy days, you're going to have to take that into consideration. And you're either going to have tanks where you've got reserve, say a 3-day water reserve, or maybe you're going to have battery backup so that those days where you don't have sunshine or your sunshine is not as much, you'll still be able to pump water. And if you do that, you've got a little bit more maintenance to consider with the batteries. So here's an example of a solar pump. You got your solar array there. There's a well. On to the right, there's a large tank that's got your multiple day water supply, and then the tank that's actually the water source for the animals. Here's another one, same kind of setup coming from a stream. And here's the typical layout. It's a pretty simple system, a well to a storage tank, pumps powered by the electricity generated by your solar array. Windmills, also an option. Windmills can run generator, a piston pump, or air compressor. And again, because, like a solar pump, wind comes and goes. And so you're going to need to have a reserve supply of water for a windmill, just like you would with a solar system. Diesel-powered gas pumps, they're, an option. Again, these will need to be protected from livestock. They are portable, typically. This particular one that's shown is maybe not as portable, but there are portable gas or diesel-powered pumps that are available. I want to mention nose pumps real quickly. It's another type of pump that's available. These kind of pumps, they're a little on. They're going to run you about $400 for a pump, and each pump will serve maybe 30 to 40 cow-calf pairs. You have to train the animals to use these pumps. They are portable. There's no power required. The power is supplied by the animal. They basically pump this pump that pulls water. It's limited in how far it will lift water. It can lift water about 300 feet, and it's typically you need to be fairly close to your source. And these kind of systems only work with large animals. One other type I wanted to mention, hydraulic rams. These are a type of system where if you have a flowing source of water, a stream that's got a pretty good flow to it, you can use that energy of the flowing water to actually move water up and into a storage tank. These types of systems are good for remote locations where you've got a flowing water source. They can lift water a pretty good ways, surprisingly. They are not portable. Once you put them in, they're pretty set. You're going to need frost protection. They're economical to operate, but they're costly up front. So we've come to a point where I'm going to pause for a minute and ask Kevin if we've got any questions so far.
Just one, Bill. People were wondering if do you recommend testing water from all sources or just certain sources, or how do you address that?
Well, I would suggest that depending on where you are, you're going to need to test water from most sources. Municipal sources you're probably not going to need to test from, and wells, depending on your location, you're probably not going to need to test from. But some wells, depending on sometimes you can have shallow wells. Those kind of wells you're going to probably need to test. If you're in a coastal area, you may have some saline. You're going to need to test those. In terms of your surface water sources, I would recommend testing those as well. Water tests are pretty simple and pretty cheap. Would you agree with that, Kevin?
Yeah, I would. And when people go to the handouts after the presentations today, there's a couple of good handouts that you've put on there for people to look about quality of water that's needed for livestock and that kind of thing. So, yeah, I think that's good. That's the only questions I've gotten so far.
All right, good. Let's move on. So now I want to talk a little bit more about some actual design considerations, some information that you need to know to design one of these systems. We're going to talk a little bit about location. You're going to need to know numbers and types of livestock. I've got mentioned here seasonal versus annual. If your water source is a pond or it's a flowing stream, you need to know things like, is that water source there all year long? Because some streams, are ephemeral in nature and they'll go low. Same thing for ponds. Depending on how big the watershed is for that pond, are you going to have enough watershed? Are you going to have enough water available? If you're using a spring as a water source, if you've got a spring and it's based on high water table, is that water table drop down during a certain part of the year? So you need to take those kind of things into consideration. How many troughs are we talking about? Is this a single trough that you're going to move? Is this a portal system, one trough operating at a time? Or are you going to have multiple troughs operating at a time? Because your design is going to vary depending upon which you've got. I wanted to mention quickly that we are currently working on a tool that will be in the engineering field tools. That will be available. This presentation is being given in June of 2013, and hopefully in the next year we'll actually get a pipeline tool, an engineering field tool. We also have, many states have got state-developed design tools, spreadsheets, and or fillable forms that are going to help you with design of these systems. Contact your area engineers. They can get you in touch with those tools if you have the appropriate job approval authority. Let's talk a little bit about location and layout. We're going to want to locate our troughs in areas that are away from sensitive areas. We need to know distances from our water source to where our troughs are, elevation changes as well. If we're going to have multiple troughs, the way that we typically design these systems is if you have one trough operating at a time, you're going to move one herd from to different paddocks or pastures. You would design a system for basically the worst case of your multiple troughs, the longest distance or the one that's got the most elevation change. You may have to check the multiple troughs to see which one is your trough that's going to set your design, but you would do it for the worst case design. If you've got more than one trough that's operating at a time, you'll need to make sure that you've got enough flow rate that can handle more than one trough at a time. So that's a bit more tricky kind of design, and most field folks are going to be turning those kinds of designs over to engineers to make sure that they're properly designed. Kevin's going to talk a little bit about paddocks and sharing, but you need to know how many paddocks you're going to have, how many connections, where are those connections going to be. Design flow rate. We need to know what flow rate can we handle in our system. Because remember earlier I talked about tanks and sizing. Do we need a large tank with extra storage, or a small tank that's able to fill fast enough? If we've got a well that's limited in how fast it can supply water, you're going to need to be able to store it. Peak demand, if you've got a fast source of water, one that you can draw from quickly, you can size a system more to meet a peak demand event rather than trying to store water in a larger tank. Let's talk a little bit about pump and pipe design. As I mentioned earlier, these systems are designed that the pipe hydraulics is very similar to an irrigation system. So if you want to know some of the how-to in pipe design, look to the NRCS irrigation guide for some help with that. And there's also engineering field handbooks that have pipe hydraulics. Basically what we're going to be doing is you have to calculate the total dynamic head in order to size the pipe and size the pump. That head is a function of four main considerations. What's the elevation difference between the source of the water and the ultimate delivery point, the trough? How much friction loss do we have to overcome in the pipeline? Some system operational requirements. For example, our float valve. Most float valves are set to where you have to have 10 psi to open the valve. So you have some system operational considerations like that, a minimum of 10 psi at the trough. Other things like minor losses that need to be considered. Elevation difference, pretty simple. We need to know how much difference there is in elevation between the source and the trough, how much distance there is from point A to point B. It's important to know elevation difference because as you change elevation, that change in elevation impacts the amount of pressure that you have to overcome that change in elevation. So if you're going uphill, you got to have more pressure to overcome going uphill, and if you're going back downhill, you need to know that too, because you can actually get excessive pressures going down long slopes because you actually have a pressure buildup going down that slope. So elevation difference, and we need to know that whether our source is an open water source like a pond or a groundwater source. Talk a little bit about pipeline. The typical types of pipeline that we're going to see are PVC. Here's an example. You see a buried PVC pipe. There are some cases where steel pipe is used. It's not typical because steel pipe is pretty expensive. The pipe that's used most often is the HDPE, the high-density polyethylene pipe. Some of the consideration factors for pipe design, the velocity of the water moving in the pipe affects friction loss. In this example, we got a velocity of say, basically 3 feet per second, and the pressure loss over 100 feet is 1.6 psi. Same size pipe with more velocity. Now you're going almost 6 feet per second, and the same 100 feet has more than double the loss. So velocity has an impact. Inside diameter of the pipe, basically your inside diameter affects your velocity. So that's why this is important. Same kind of thing, bigger pipes. One of the ways that we cut down on friction loss is by making the pipe size bigger. The length of pipe, I mentioned earlier, length is important. The reason length is important is because the more length you have, the more friction loss you have in that distance. So longer length, more friction loss. Talk a little bit about HDPE since it's a very popular pipe. There's a couple strength ratings that are typically used, 160 psi or 200 psi. A couple of things about HDPE is that as temperature increases, the pipe loses strength. It also changes the length. Here's an example. Here's a picture showing some HDPE pipe. When we're talking about pipe, we need to take into consideration freezing. And if we're at a point where we could have frost penetration, we'll need to bury pipe different depths. Some places we may not have to worry about it as much. Installation, and remember I said HDPE expands and contracts. It can expand or contract 2 to 3 feet per 100 feet with just a normal temperature change during a day. If you have a drier area and you can have a temperature swing of over 10 degrees Fahrenheit, you can get some pretty significant distance change. Why does that matter? Well, you don't want to install the pipe in the heat of the day, and then when it gets cold, the pipe contracts and it's going to pop your connections. So we typically recommend laying out the pipe during the warmest part of the day and then connecting it in the coolest part of the day. And here's your pipe again. Shallow burial, there are tools out there. There are ditch witches or other tools that are used for burying pipeline. And it does come in rolls of pipe, the HDPE does. In addition to pipe, the losses caused by friction, there's other losses that we're going to need to calculate and count up. These are things like minor losses. There's 2 ways that we typically do that. One way is that we just add 10 to 15% to the pipe length. Simple systems, just add 10 to 15%, and that should be plenty of extra friction loss that are going into your equation, your calculations to cover all your minor losses. The other way to do it is to actually add up the loss for each and every fitting, which means you take into account every flow valve, every check valve, every release valve, low pressure drains, T's, elbows, pressure reducers. You count all those up because each one of those is going to cause a pressure change. Now, I talked about fittings here a little bit. Some of these are pretty obvious. Check valves keeps water from flowing back into your source. Flow control valves turn on and off the system. Let's talk a little bit about air release valves. Well, maybe we'll talk about that in a minute. Pressure loss in fittings. We have an equation that we can use. There's tables that have K values that we pop into equations that will give us the friction loss. Those tables and those calculation methods you can find in typically in an irrigation guide. Sometimes they're in the state supplements for your irrigation guide. Air in pipelines. So, air in pipelines, we don't like to have air in pipelines because it can cause, us to lose efficiency. Pipe damage can occur. Things like water hammer. Although water hammer is not typically a problem in livestock watering pipelines because of the size. It's more of an irrigation type problem because of the higher pressures and flow velocities used in irrigation systems, but can occur. So we want to do things that remove the air in the pipeline. Also, we want to be able to drain when you drain the water out of a pipeline when you turn off a system. So here's an example of where we would use some air release valves and some drains and why we would use that. Typically, you would have drains at the low points in your system, and you'd have air release valves at the top of your system, and you could have also some vacuum valves that are needed in there for points along your system. It basically drain valves, what it does is when your system turns off and you get a low pressure, the drain will then let the water drain out of your system. And this is really important when freezing is a consideration and you don't want the water to be sitting in your pipe so that it can freeze. And then the air release valves. When you turn on the system and water comes into your system, you need some place for the air to go, and it can go out the air release valves. Here's an example of an air release valve on an HDPE pipe. Location, typically high points in your system. If you've got quarter-mile long grades, you'll put an air release valve in there. Always have an air release valve at the end of your system. Vacuum release valves are typically they're not needed. They're there to keep pipe from collapsing when from a suction or a flow back. Pipes less than 3 inches diameter typically don't have that problem. But I mention it because it's important to think about and make sure that you know that it's not needed. Talk a little bit about pressure tanks. We have pressure tank systems. These are typically right next to your pump. You'll have a tank, a switch that controls the water into the tank. It's for things like it's going to reduce your susceptibility to water hammer. Tanks can also supply a little bit of storage. They keep things like that. You don't want your pump to cycle on and off. Turn on for a minute because the cow's drinking and then turn off. Turn on for a minute because the cow's drinking and then turn off. You want it to not cycle your pump on and off as often. So by having a pressure tank with a little bit of storage and a pressure on and off switch, it keeps your pump from turning on and off, cycling on and off more often, which is better for your pump. So here's an example system. You got the tank itself is the big red thing there. This particular tank is probably going to hold about 50 gallons. You got your well going down into the ground there. You've got a shut-off valve, the pressure switch that's there that controls when to turn on your pump and when to turn it off. Here's an example of what your pressure switch looks like, and most of these will have some sort of setting on them. Typical settings are, say 20 to 40 psi, and what that means is that the system will turn off when it gets to 40 psi. So the pump kicks on, and it pumps into the system until it fills up that pressure tank to 40 psi. Once the tank's up to 40 psi, it turns off, and it won't turn back on again until the pressure goes back down to 20. So that's how those systems work. And the size, what that bottom number is, 20, 30, or 40, that depends on what your system needs. So if you need from the tank to your trough, you need 30 psi to get it to the trough. you'd need a system like the 30 to 50 PSI. Let's talk a little bit about couplers. Here's an example of a quick coupler that you would find on an HDPE pipe. If you have a buried pipe, you can have something like this where you've got a PVC going into the ground, so you have access to your coupler. Here's another quick coupler connection. This is at an end point or maybe an off spur, off a teed off point. Here's where you actually access the quick coupler in. That's what it looks like. What these allow you to move tanks around in the field. You can have valves to control where you're sending water to which tank. Tees. These systems, if you notice, are pretty easy to put together. If you look, you got some pipe bands that are there for attaching the HDPE to your different valves and your tees and whatnot. Very easy to use. These pipes typically go along, you'll notice in this picture, the pipes go along the fence line, which is a good place to put pipes that are on above ground like this. Keeps them out of the way of the livestock, keeps them out of the way of equipment. The pipe color here, this HDPE pipe is black. Sometimes these pipes will be white because it'll keep the pipe cooler, but a lot of times you'll have grass or vegetation that grows up a little bit on your fence rows, and if you put your pipe down underneath that vegetation, as the vegetation grows over it, that actually helps to cool your pipe system, which is usually a good thing because cows would prefer to drink a cooler water than a warmer water. Let's talk a little bit about float valve and pressure. So what's the minimum float valve pressure that a valve would need? Many of them are 10 PSI. But we also need to consider maximum. Some of these systems will have a maximum pressure that the float will withstand, and we need to know that, especially for systems where you have multiple troughs. You're going to want to make sure that trough that's closest to the pump doesn't have a pressure that's too high and actually never lets your float valve close. Here's a float valve, just look at a picture of it. Some of the valves are kind of like this float valve that's in your toilet. You got a float that as it goes up, it turns off the system. When it gets low enough, it opens the valve and lets water in. Here's a system for a tire tank with a float valve. The little float is that yellow thing there in the middle, and as that float goes up high enough, it's going to turn on, or as it gets low enough, it's going to turn on the system. As it gets high enough, it turns off the system. I want to mention here for a second while I've got a picture of a tire trough up. That I know tire troughs are one of those things that are used in some states and not used in others. Tire troughs, sometimes they can be a good alternative. They're not always the least expensive alternative. They can be the least expensive, an inexpensive alternative when you want a permanent tank. But obviously, these kind of systems are going to be more expensive than your portable tanks. I will mention that some people look at tires and used tires and say we can't purchase those because it's used equipment. Well, in reality, it's not it would be used equipment if you're going to give it to somebody to use on a tractor, but we're not doing that. We're repurposing this tire. So actually, a used tire is a material for a new water trough. It's not a used material. So if you run into that question, there's an answer for that. Here's another tire tank and valve. And the little inset picture there kind of shows you, how it works. Similar to this, in this case, similar to the tank valve that you find in many toilets. And here's another tank. This is a little float valve. This particular one is, a very simple one for a small one, and it's hooked up to a hose there. All right, back to pump design. We're calculating TDH and sizing the pump. Again, we talked about, calculating elevation differences, calculating friction loss, knowing what that operational requirement is, what does that float valve need to open, and adding up our minor losses. If you have that kind of information done, it will go a long way to helping you calculate that total dynamic head and sizing the system. I'm going to point you towards a reference. Chapter 6 of the irrigation guide. It helps with pipe hydraulics. Many state supplements are out there that will have added information for pipe hydraulics. I want to mention thanks real quick to Jeff Duchesne, Kevin Ogles. They provided some great pictures for me, and the Missouri and Oregon NRCS publications that are included in your handouts. I got some of my pictures from those as well. So we're to a point here where we're going to break for questions, and then we'll go on to Kevin's portion. So Kevin, any questions out there?
Yeah, we've had some come in. First one was, what would be the best way to determine the flow rate from a spring if there were no prior records existing?
So the best way to determine the flow rate is going to have a lot to do with the size of the pipe that you're using to collect your water and when that water is there. I mean, springs are one of those things. It's typically a drainage system, and a drainage system will provide water out the end based on the size of the drainage tile, as long as the water is there. But the big question is, what time of year? Is the water always there? Because high water tables come and go, and same thing with seeps on the side of a hill. And there'll be times of the year when those water sources are available, and times of the year when they're not. So that's a more important question. In terms of calculating the flow rate, it's basically you're going to use your drainage equations to come up with what that flow rate is. Talk to an engineer. There's a National Engineering Handbook on drainage that can give you what that amount is. But that amount is, going to still be dependent on if the water's there at the source. So hopefully that made sense.
Sure. Okay. Here's another one. Where would be a situation where you would use a hydraulic ram pump?
Typically you see those in remote locations where you have a lot, streams that are steep and you have flowing water. Remote locations where it's difficult to get other power sources to. Those would be ideal times when you want to use a hydraulic ram. You don't see them used a lot. I mentioned them primarily because they are there. They are expensive. I'll give you an example. Let's say you're on the north side of a mountainous type area, and you've got a flowing stream nearby. Because you're on the north side, your amount of sunlight is going to be more limited, so that's going to limit your solar options. If you're in a mountainous terrain and you're away from electricity and municipal, it's going to limit those options. So, that's one of those kind of cases where it's an option. It's expensive, but, sometimes you have to go that route.
Okay. Let's see here. There's a lot of questions popping up here now. A question about if are states installing wildlife escape ramps, and keeping the water surface clear from overflying bats.
Let's let that one wait till your presentation, Kevin.
Okay.
And let's take one more, and then we'll go on to your presentation, and then we can come back and have more questions for either one of us after that.
Okay. Well, then let's do this one. Are the tops of the troughs, I think they're talking about a tire tank here, are the livestock protected from harm by the steel belts that are in the tires? That's what they're wanting to know. Is there protection to the livestock if there's steel belts in the tires and they're using them for a tire tank?
I would try to choose a tire that wasn't steel belted. A lot of your flotation, your large tractor tires don't necessarily have steel belts in them. So that would definitely be a concern of mine as well. Choose one that doesn't have that. Otherwise, you're going to have to cap it with something, and that just adds time and expense and operation and maintenance to a tank that is already, expensive compared to other options. I mean, they can be, there is expense to them. So many tractor tires that are used don't have steel belts. All right, so I'm going to turn the presentation over to you.
Okay, watering facility design. Now, Bill's covered a lot of this already. So I just want to highlight some things here. Determining need. How much water do we need? Bill talked about that. You got to design for the demand. There's lots of things that affect intake. That was covered also in the earlier webinar that Bill referenced to that Michael Hall and I did. How fast? That was also covered there. That's an important consideration. Under what climatic conditions? We tried to cover the thermal heat index concept, and there's a good handout that we put at the end of today's presentations. When you look at the handouts, there's a good one there about the thermal heat index that will greatly affect how much water livestock need to drink. So I'm just going to touch on that today, but I'm mostly going to talk about what are the animal behavior impacts that need to be considered. First of all, people need to realize that there's very few scientific trial results published on livestock watering. Very little information on any livestock besides cattle, and what there is on cattle, there's more of it on dairy than there is on beef, but it is very, very important. It's essential for cattle and for all livestock. Water intake, just highlighting some things that was covered in an earlier webinar, but just realize you need to take into account at times when there's plenty of water in the forage. There's a couple times a year where that's a big factor in the east. And also any other sources. We've worked with lots of dairies that have converted from confinement operation to a grazing-based dairy, and they still have a tank right outside the parlor. And so then sometimes that's been missed when we've got ready to do our designs. So a little bit about this thermal heat index. And like I say, you can look at the handout on that, but when animals are in moderate heat stress or higher, a distress level, for only a few days of the total grazing season, a contingency plan of action's got to be done for those few days. I try to tell people that I provide assistance to that when we're doing our planning, we understand all the reasons about fencing out streams or ponds, lakes, but there also needs to be some plan there for an emergency. I always recommend a gate to get back in there in emergency. It's not uncommon, especially during thunderstorm season, to lose power. Sometimes, for a few days, and those animals can't wait for a few days to get a drink. We also don't recommend sizing the tank just for those few days. I'll talk more about this later, but one example, I helped Michigan. We looked at some weather data, and only 1% of their grazing season had days where the animals were going to be in moderate heat stress. So we didn't recommend sizing the tank based on those few days. So something I just kind of pulled out of my hat, actually from talking and observing what farmers have told me and some of my East State grazing specialists, that if 15% or more of the of the growing season, so that's from last frost to first frost, that if 15% or more of those days are in moderate heat stress, then we need to make sure that we do provide for that higher water intake. An example is we also did a little work, Montgomery, Alabama, 25% of their growing season days, animals would be in moderate heat stress by the thermal heat index. So then I get this question asked a lot, okay, Kevin, so where's the line? North of that line, you don't really need to worry about those extra amount of intake for the livestock, and south of that line you do. Well, that's not an exact line. So this is my estimate, and if anybody from anywhere wanted to argue with that and say we think that's wrong, that you'd be just as right as I am. But something around the 41-degree north latitude line seems to be, when I looked at some National Climate Center weather data, seemed to be kind of where that thermal heat index, where it happens very few times north of that line, begins to start happening 15% or more of the time south of that line. But you also got to consider the mountains, because there can be low heat stress days on livestock even in the mountains of Alabama and Georgia. This is something we covered in an earlier webinar, but Jim Garish's famous work that he did, where he looked at if animals were, especially cattle, were within 800 to the 1,000-foot range of water, only 2 to 5% of the herd would come in a time to drink. If they were farther away than that, then 10% of the herd would come, and we've observed several times where the water was a quarter mile or more away, 25% or more of the herd would come. Also, Bill talked about the peak demand. So based on how many animals we think are going to come to the tank on our design, remember they drink 1 to 2 gallons a minute. They'll drink for 2 to 3 minutes. If you use the maximum of those 2, then we need to allow for 6 gallons per drinking event per animal in the design. Here's some important things too. Now we've included some handouts. Missouri's got a great handout that we've got there, as well as Oklahoma State. Lots of good information, and you'll see headspace that needs to be accounted for on a tank, and you'll see everything from 15 inches to 30 inches, and I just want people to consider it in planning. A lot of times we find out that people haven't done that, and that's real important, that if you're planning on so many animals drinking at one time, there better be headspace enough for them. And if it's a circular tank, then it's a little less than that, obviously because of the round versus linear. Bill already talked about how they prefer moderate temperatures of water. Depth of it at least 3 inches. You may not think, well, that would be much of a fact to worry about, but cattle like to put their muzzle in 1 to 2 inches deep in the water to drink, and so I've seen cases where the water wasn't that deep, so it was important for the cattle to get the amount of water they need. 24 to 32 inches is the range for the height of a tank for cattle, and I'll talk here in just a little bit where that was a big factor. So here's a study done. This was also by Jim Garish and Maurice Davis, who used to now retired NRCS employee. But they did some great work there on water intake here on dairy heifers, and just noticing as it gets hotter how that gallons of water per day needed really increased per animal. So there we're back to that heat index thing. If we got a lot of days where the amount they're needing is that high rate, then we're going to have to design for that. Whereas if you're going to have very few of those days, then you wouldn't have to have as many gallons of water per day per head. Here's a really good design. Greg Brand sent this to me from Tennessee. Really just lots of good things happening here. 4 paddocks here are able to use the one 4-ball water, and so animals were able to get a drink. And I've seen designs where a similar system, you could probably have 6 or 8 paddocks coming to this one spot. We did want to talk about wildlife, as Bill mentioned. It is in the national standard. Here's some excerpts from the national standard. So the first one is in criteria. So criteria is not optional for us. When we're doing planning, we want to incorporate escape features in the watering facility design unless local knowledge and experience indicate that wildlife will not be at risk of drowning. Also in considerations, it talks about things that can be a hazard or a barrier to wildlife that gets their drink on the fly, which is bats and some birds. I'm not a wildlife biologist, but I got my information from them here at the Tech Center. And also I just wanted to mention the west versus east discussion. It's very important, obviously, in arid areas of the country where water is hard to come by. So wildlife obviously know that too, and so they'll use the livestock watering a lot. And so a lot of people have asked, is that needed in the east where, you know, we're blessed when you got 40, 50, 60 inches of rainfall with a lot of water in lots of places. And so in my career, I've known of 3 cases where I've seen or heard about firsthand where wildlife had drowned in water tanks. And so it can happen in the east, and the webinars that have taken place in the past about this, I watched one about a year to 18 months ago, and it was very good, and it talked about how they're going to start doing those studies in the east. So we'll actually have some information about how big a factor that is. And so, again, just to highlight those, allow an escape for wildlife that fall into the tank, and try not to hinder those that drink on the fly. So things that can be in the way, any kind of material within 36 inches above the water surface can affect it. And there are ways to, by moving these portable tanks especially slightly, it could still be used by wildlife as well as still provide livestock water to 2 different paddocks that are sharing the tank. Here's a picture of what one of those escape ramps look like in a tank, and yes, they are used by wildlife. Just brought this picture back again, just talk about how this type of setup is also not a temptation to wildlife in getting a drink on the fly. So another advantage to this type system. Just want to talk about how one of the things when I first heard about the wildlife in the east, I was one of the ones that was like, well, I don't think that's a big factor. Why are we worrying about that? But the longer I've worked and a lot of systems I've seen, usually where we're trying to get the tanks to be used by the maximum amount of headspace for livestock, the better off we are, and that also is better for wildlife, those that are drinking on the fly. So here's a portable tank that's been put up against where the end is against the fence, versus this where the tank is the flat side's against the fence, so there's less headspace for livestock to drink from it. And it's just important that we make sure we got the amount of headspace we need for the number of livestock that are drinking from it. Here's a in-place tank. Bill showed one of these also. Just what I wanted to mention about this is just last year we went to a site to look at a NRCS design and installed tank, and the tank was, instead of being 24 to 32 inches off the ground for cattle, it was at 37 inches. And the landowner installed the tank, waited a few days for things to get good and set, and then turned in his cow-calf herd, and the calves could not drink out of it. They weren't able to get their necks up and over the tank and get their muzzle down in to get a drink. So it really matters what heights those tanks are. There are definitely some things to avoid when we talk about cattle and water, besides piranha, that we want to look at. So here's the situation. Wildlife biologist gave me this, again, talking about the wildlife, how this would be a hindrance for the flying insects to drink. But I wanted to also point out, now I don't know how wide this is. We can't tell that from the picture, but we can tell it's very deep pasture. Looks to me like a long ways, longer than 1,000 feet. And so it makes me question when I see something like this, is this enough headspace in this one pasture for the number of cattle that are going to come and drink at once? And why that's a big deal, some people have said, well, they'll just wait, won't they? And actually, it's been documented that a lot of times they won't. The timid cattle in the herd, everybody comes to drink, and they're made sure that they're kind of pushed around, bullied, and so they get to drink last. And sometimes if the majority of the herd is moved away from the tank, they don't want to be left behind, so they'll go with them without drinking. So obviously that really affects their health. Here's one again, kind of a moderate level of being efficient for wildlife to get a drink from it, but also, again, this looks like really big pastures to me, so I would want to make sure that the design had calculated the right amount of headspace for the number of cattle that are going to drink there at once. Kevin Kai has sent me this from Vermont. So a lot of grazing dairies. So obviously for a lactating dairy cow, water is really important. And so we can't see all the pasture here. It looks like it's fairly small pasture, so only a few animals are going to come to drink at a time, but we can see here only a couple can drink at a time, the way they've got the tank set there. And so then the question I have is, okay, well, if that's 5% of the herd, then there better not be more than 40 cows in that herd for those livestock to get a drink. So that need it. Just a few other slides here. Here's a calf in a low tank and without boards to keep them from going through. They're able to climb into the tank and then come out the other side. And so this wasn't very far away from a highway, so this was important. Another picture I took, just again showing that if we're doing a good plan, a good design, and these animals aren't going to be in here a few days, this is a great situation. If they're going to be in there a long time, then we've got too many things there together: water, shade, mineral, fly rub, just too many things there that makes it easy for them to camp out. And when they camp out in an area where they do stay too long, then we can build up nutrients, and then that water could go right on down to the stream, like in this picture. And we want to try to avoid that, and we've seen that even with portable tanks. However, if our planning's doing good and we're moving those animals in quick rotations, not just for the forage benefit, but also the damage that might occur around the tank is very little, and within a month you wouldn't be able to see where that tank was. There are times, as Bill pointed out, where people leave the animals in too long, or where the water's in there too long without being disturbed, and the animals the design wasn't right for the animals to come and drink often enough, or that water's staying still too long, and then we can have algae problems. And I witnessed firsthand when I was a district conservationist, had a neighbor who had 2 cows, dairy cows, very expensive dairy cows, die very quickly from drinking out of a pond that had algae. So this is Bill's picture again. Yeah.
Kevin, can you go back one slide?
Sure.
We had a question that came in that's relevant to that slide. Could you use pool chlorine tablets to control algae?
You can. There's again, I'm going to point to that handout from, I think it's Oklahoma State, that we provided to this presentation. Yeah, you can have chlorine in there, but obviously you don't want to get the chlorine at too high of a level. It can get too high for cattle also, just like people. So yes, that's one way to clean it up. Copper sulfate, I think, is another way. Okay?
Yes, thanks.
Okay, we'll move on here. Bill showed this picture, and I just wanted to point out nothing wrong with this picture. It's got the flattest side to the animals, so they're trying to use the most of this tank and still share it between 2 paddocks. But there could be an improvement on this. They could turn this tank and move it just a little bit. Probably put a hot wire, go ahead and put across, and put the tank out there just a little bit, and moorhead could get around that tank, and then it wouldn't be a hindrance to wildlife drinking on the fly as well. Here's something, Robert DeClue from New York sent me this, but I've seen similar situations, and it's not the size of the tank. If the design's right, you can, for the right size herd and that type of thing. I've seen herds drinking out of a 25-gallon tank, and everything worked fine. All the cattle were getting the amount of water they needed to drink. But obviously here, that electric wire is within like a ½ inch of the lip of that metal tank, and so that's not good. And it's interesting to point out that in Northeast Organic Dairies, the company that they're under contract to, they want to see all electric lines 6 feet above the water surface because of its impact on the cows drinking the water. So for sure, we do not want to have electric lines that close to the water. That's just asking for a problem. That's all I had, Bill, and I don't know if we got time for a few questions we've gone over, but there's our contact information.
Yeah, let's go over a few questions. We got a question that came in about float valve pressure and why is there a minimum pressure to open, and it has to do with the mechanism on those float valves. You want there to be a spring or something that's going to close that valve and to shut it off. And to overcome that pressure, you're going to have some minimum float pressure. So that's why you have a minimum pressure to open a lot of float valves. We had a question that came in about HDPE and black versus white, and What's the cost differential there? I'll have to say I'm not, Carolyn, I'm not exactly sure what the cost differential is. I do know that white it can be quite a bit more expensive. And you also asked a question about deterioration with the pipe. The same goes for PVC and for the white HDPE. There are additives that the manufacturers can put in that will make white PVC or the white HDPE UV resistant, but that adds a cost as well. And in terms of design life, we do want to make sure that our pipes are able to make the design life for our water trough system. Somebody mentioned that quarter turn valves they don't like them because they can break off cows and kick them. That's a good point. Full turn types of multiple turn types of valves can be better. You get less of a lever there to break. So if the valve is something that's going to be closer to where cows would have access to, that's a good point. Somebody asked a question about spring development and can that impact wetlands? That's an excellent point. And the spring development standard has a lot of discussion. It does talk about wetland impact in the standard. And yes, you can't impact wetlands, but you can put in a spring and not impact wetlands. It has to do with the depth of the water table, the depth that you're putting in water, and what's the land use type where you're putting it in. If you're putting it in a pasture area that's prior converted, that's not going to be an issue. Somebody asked a question: is air vent needed if the valve is if you have a trough that's say at the top of your system? Is an air valve still needed for the top of the system? And that's a tricky answer. For most livestock watering situations, the answer to that's going to be no. You wouldn't need an air valve, because as soon as the tank valve opens, the air will be able to come out. The only time that's going to be an issue is for really big systems where water hammer might be an issue, because that float valve is fairly sensitive in some cases. So the answer is really it depends, but most likely it's not going to. You wouldn't need an air valve, an air vent right there if your trough is at the very highest point in your system. What about another question we have? What about flow drains for when a float fails? And in my experience, sometimes you want to have it be very obvious when that float valve fails. So having an overflowing trough might be a good signal to somebody who's driving by that there's a maintenance step that's needed. The times that you see overflow drains in tanks are times when you have water that's coming into the tank all the time. For example, you have a spring that's flowing open source into a tank, or a roof gutter that's guttered into a tank, and you're going to want an overflow out of that. And the only reason you really have an overflow then is so that you can control where the water leaves the system for erosion purposes. So, it's a consideration. From a float valve standpoint, I'd like it to be as obvious as possible when that thing fails, so that it gets maintained as quickly as possible. So, all right, let's look and see what other kind of questions we've had out there. Kevin, we had a question that came in for you. What about, somebody else wants to know, if you have a tank in your system where you had a tank in the center of 4 lots, what about putting fences all the way around that tank, having it open, and being able to open gates so that cows can get in and then have access to the whole tank rather than a sectioned off part of the tank.
Yeah, absolutely. Yeah, any time we can increase the number of animals that can get a drink when they do come is a good move, and probably with a little bit of thought and design, there'd be a way to do that probably wouldn't be a whole lot more expensive than one of those last slides I showed with the round tank being quartered up by the 4 different pastures. So yeah, that's definitely a good idea, and that could work.
So Kevin, somebody wants to know what's the difference between a tank and a trough.
I don't know.
That's like you say tomato and I say tomato.
Yeah, that's an age-old question.
Northern, southern thing. I'm not sure.
It's definitely part of our American, colloquialism in our language. So I don't know the difference.
Does a 55-gallon drum meet the life requirements for troughs?
It could.
If it's a steel tank. Programs question. We'll kick that to programs. Let them be the bad guy on that one. Let's see. Can you remind us where the handouts will be accessed? So those are at, is it conservationwebinars.net? Holly, you still?
Yeah, that's correct, Bill. The same page that was used to join this webinar, that's got the picture of the animals at the water trough and that previously had the join button. If you'll scroll down past the image, there's a number of handouts there that you will download primarily as PDFs, and I think there's one PowerPoint.
Let's see, what other questions have we got here? What about float valve protection to reduce long-term maintenance? Christian, I'm not sure exactly where you're going with that question. Let's see, what's the happy medium height if we're putting boards up across the tank to prevent calves from entering the tank while still allowing flying drinkers?
That's tough. You really can't have both because that picture I showed where the calves had gotten in, there had to be something put there, or else eventually the calves would get out of that pasture and be gone to who knows where. And so if you're going to do that, you can't have that 36-inch open space that the wildlife biologists tell me is needed for wildlife to get a drink on the fly. So I don't think, and wildlife biologists, if they correct me, we'll get back to you. But I think you have to either choose one or the other in those cases in an existing tank like that. Now, if we were going to design something for new, then yeah, there'd be ways that we could do that so that we could provide for both.
We had a couple questions that came in asking about heavy use area and the size of that. Sorry, we didn't have a chance to cover that in this presentation. Maybe we'll get to it on a future webinar. Carolyn asked a question, where it says basically a tank is a water storage facility, a trough is where the animal goes to drink. Okay, Carolyn, I'll take your word for it. Do you have information about pricing troughs on range ground in the western states where the pastures are much larger than those being discussed so far? You want to address that one, Kevin?
Well, I don't have any information, but I would think that the West Tech Center and Central should have some information. I know my counterparts are Charles Stanley in the Central and Gene Fultz in the West. They should be able to have information or get you information about that.
Do we need to account for more headspace needed when designing the size of the tank, or design it based on the number of gallons that are needed for so many head of cattle? The answer is it's both. So you're either going to have a design where you're trying to, you got to consider, first of all, how many cows are going to come to drink at a time. And Kevin mentioned the herd mentality. The further you are away from the trough, the larger your pastures, the more cows that come and drink at one time. And when they come and drink at one time, you want enough headspace because that herd that comes will only stay there for a certain amount of time. Kevin covered that very well in his other presentation, so I'd encourage you to go look at that. In terms of the gallons that are coming in, you want to be able to meet that peak event of drinking. So if you had 6 cows that are drinking at, yay many gallons per minute, you want to make sure that your source of water is able to meet that demand. Otherwise, you have to have a tank that stores enough water for an entire drinking event, and that sizes up your tank size. So it's one way or the other, and you got to look at it from both perspectives. Are there significant water quality issues with using old tires for livestock watering facilities? The short answer is no. You can clean up those tires. They're rubber. They are made from an oil product, but if they're an older tire, there's lots of history with using used tractor tire tanks. So that's not an issue. Wow, we're going to have to cut questions off here pretty soon because we're getting pretty late. Those of you that didn't get your questions answered, I encourage you to contact myself, Kevin, or our counterparts in the Central or West. Let's see if I can't find one more question here to finalize us. Sometimes we design watering systems for goats, sheep, etc. Where can we find drinking habits about animals other than cattle? So, Kevin, I picked the last question for you.
Yeah, thanks, Bill. Yeah, and that's a tough one. As far as research, I don't think you're going to find any. I'm not saying I did an exhaustive search when I was looking for that stuff, but I tried to find anything I could. You can find some stuff on intake, and you can find some non-researched observational stuff about goats and sheep, or even alpacas, bison, whatever other kind of livestock besides cattle that people are raising. But so you can find enough information, I think, to do the design. It's just that we don't have. You're not going to be able to find, well, this is how many percent of the flock comes at a time if it's within this distance. There's just not been that research done.
All right. Thank you, everybody. Holly, have you got any final words?
No, just that there were an awful lot of questions that came in, and we appreciate your attention today. Appreciate everybody's participation. Thank you.